Welcome to 6502 Assembly Language Programming. In this video, we'll look at arithmetic instructions. The 6502 has two arithmetic instructions: add with carry and subtract with carry. But there are three supporting instructions: clear carry flag, set carry flag, and clear overflow flag. These do not perform arithmetic in themselves, but set the stage for an arithmetic operation forthcoming. Add with carry and subtract with carry are both 8-bit operations, and their implied object is the A register, also known as the accumulator. The carry flag is useful in adding or subtracting values requiring more than 8 bits, and it's set when an arithmetic result overflows 8 bits. For example, adding hexadecimal F0 to hexadecimal 20 will equal hexadecimal 110, which does not fit into 8 bits. So in this instance, add with carry would set the carry flag. We'll look at this in the IDE. Unsigned versus unsigned arithmetic is purely a matter of how your code interprets the numbers it's working with. The 6502 treats these numbers the same. If you use unsigned numbers, 8 bits can represent values from 0 to 255 decimal, but using signed numbers, only 0 to 128, or pardon me, 127. But it's not hard to represent much larger numbers by using more bytes, more than one byte, excuse me. In signed arithmetic, the most significant bit indicates the sign of a number using the 2's complement system. To derive the 2's complement of a number by hand, you would invert all the bits and then add 1. So these three numbers here illustrate this process. You start with this binary number, you invert all the bits, and then add 1. And this bit string here is equal to -9 in 2's complement. But don't worry, the 6502 handles this automatically. The overflow flag lets you know when an addition result overflows 7 bits. In other words, it cannot be contained in 7 bits. So, when you add hexadecimal 4 to 7F, the result is 83, and the overflow flag is set. There is no underflow flag. When a subtraction results in a value less than 0, it sets the carry flag to communicate that result. But oddly, the flag is set to 0 on an underflow and is set to 1 otherwise. So let's go to the IDE to see this. Let's have a look at how the carry flag works. But first, let's talk about saving your work. I hope that you watched how to save your work, but if not, there's a link in the description. I'm going to go to the course source files and click Solve the Exercises. Now here, let's look at EX0. Even though I've solved this previously, you can see that my changes are not here. So let's go to the Files tab and click Load. Going back to source, you can see that my changes are now loaded. Now going back to the Files tab again, I want to mention that Play Atari preloads the project name to course, and I had previously saved a project by that same name. There's a lot you can do here, and again, there's a separate video telling you how to do that. For now, let's go look at how to set the carry flag, or maybe more properly when it's set. And for that, we want to go to EX1. So here we're going to clear the carry flag with CLC, load the A register with hashtag meaning immediate, $ meaning hexadecimal, FF. Oops. Then we're going to add hashtag $ FF to that. Let's go see what that does. In the Run tab, we're going to go down to EX1 on the listing, and we're going to stop execution here. Clicking on a line number that sets a breakpoint. Now, looking in the CPU tab, you can see that the carry flag is set to 1. We'll step over the CLC, and now it's set to 0. Stepping over the load, carry is still 0, and we have FF in the A register. Let me change the base to 16, and you can see that it's FF. Also note that the immediate value FF is inside the instruction, and that's true of the LDA as well. That's why they're called immediate instructions. So now let's make some more changes and have a brief look at how the overflow flag is set. Going to source. This time we're going to clear the overflow flag with the CLV instruction. And instead of loading FF into A, we're going to load 7F. Instead of adding with carry FF, we'll just add with carry 5, 0, 5. Okay, let's go run that. Our breakpoint is still set. In fact, we haven't resumed execution from last time. So let's resume. And execution comes back to EX1, and we're looking at the CLV instruction. Now right now, going to the CPU tab, the overflow flag, which is under V, is 0, and we're going to clear it by clicking step over. It was cleared, and now it's cleared still. We'll click over the LDA. Now we have 7F in the A register. Now we're going to add 5 to that, and we get 85. Now 85 fits in 8 bits, but it doesn't fit in 7 bits. And so we have the overflow flag set. So now you can see the conditions wherein the carry flag and the overflow flag can be set. There is one more scenario in which the carry flag is set or reset according to how an operation goes. And that has to do with the subtract with carry instruction. So for instance, if we set the carry, the SEC instruction, and then do an LDA, immediate value 7F, and then do a subtract with carry, we'll see this happen. Click and run. Zoom. So here we set the carry flag. Oh, pardon me. Set the carry flag. It is set. We load 7F into the A register. Let's go back to the CPU tab. So you see we have 7F here. We're going to subtract 5 from that. In fact, let's look at that in decimal. 127. We'll subtract with carry 5. And you can see that now we have 122, which seems right. And our carry flag is set. And it's set even though we didn't have any sort of underflow situation, because on subtractions the meaning of that bit is reversed. A 1 means that you didn't have a carry, and a 0 means that you did have a carry or an underflow situation. A little bit different. So let's move on to actually completing this exercise. So we'll go back to the source tab, and here we'll just erase this code that we've typed. First thing we'll do is change the LDX to implemented, so that our result will be tested. And now we'll start typing. We'll start coding. So what we want to do is load what's in parameters 0, add that to what's in parameter 2, and then subtract parameter, I'm sorry, add that to parameter 1, and then subtract parameter 2 from that result, storing the answer in output 1. Okay then. To start with, we'll clear the carry. Do an LDA of param underscore 0. That is not immediate. That is from memory in the base page. And then we're going to add param underscore 1. And then we're going to have to do something quite strange. We'll have to set the carry flag. But you know why we're doing this. Because we're going to do a subtract, and we don't want a carry to be involved with the subtract. And now we're going to subtract with carry param underscore 2. Okay, let's run that. Oh. So let's resume. We've got to get rid of our breakpoint. Well, our code failed. So let's go see why. Pretty simple. I just failed to store the answer. So now I'm doing that. And let's try again. Okay, so now we've solved the second exercise. Having solved it, I am going to go back to source and click See Solution. Because my previously coded solution has comments which are quite good, I think, explaining things. Then I'm going to go save this, so that next time I've saved my work. Well, okay, that's it for now. Thanks a lot for watching this. I do appreciate it. And I hope it's been a benefit to you. If you have any questions, please ask them in the comments. I'll get to them as frequently as I can, as often as I can. Thank you very much. And as always, it really helps to like and subscribe.